In this video, we're introducing the idea of parametric equations for a curve. So parametric equations, that's where you write down a separate equation for each coordinate of the curve as a function of a parameter t. So each of these coordinates is given by a little equation, and then you plug t values into the equations from some starting point A to some finishing point B on the parameter. Now, the reason we use the letter t is because that parameter actually stands for time in a lot of applications. One other general note before we look at some examples. In some cases, it's possible to relate x and y and completely eliminate t from the equations. That's called eliminating the parameter. And that's a way of getting an ordinary equation in rectangular coordinates relating x and y. So we're going to illustrate that in the second example below. All right, let's look at the first example. It says plot the curve given by x of t equals 2, y of t equals t as t goes from 0 to 1. So just looking at a couple points explicitly, if I plug in t equals 0, x of t is just 2. It's always 2 no matter what t is. And then y of t is t, which would be 0 in this case. So I would get the point 2, 0. And I could plot that on a grid. If I look at t equals 1/2, x would still be 2. Y would be 1/2. So I'd get the point 2, 1/2. So it looks like I'm just at this fixed x coordinate, and I'm working my way up to a maximum value of y equals 1. So my third point here would be 2, 1. So this is just a little vertical line segment. And because I was putting those t values in order, in other words, as t increased, and I started at this point down here, 2, 0, and then went up to 2, 1/2, and then 2, 1. That automatically implies a direction to this parametric curve. So I already put the arrow in, it points upward. That's the direction this line was drawn. In the second example, I have a slightly more complicated set of parametric equations. I have x of t equals 2t, y of t equals t, and t is going from 0 to 3. Just looking at a few points real quick, if I plug in t equals 0, I would get x equals 0 and y equals 0. So this thing starts at the origin. If I plug in t equals 1, I would get x equals 2. That's 2 times 1. And then y is 1. So I get the point 2, 1. So I move 2 spaces to the right and 1 space up. Plug in t equals 2, and then we'll just go ahead and move the image into the slide. That gives me x equals 4, y equals 2. So the point 4, 2. So again, I've moved 2 spaces over and 1 space up. There's a picture of this parametric curve, and it looks like it terminates at the point 6, 3, which if I just verify real quick, corresponds to t equals 3. Now the directionality has automatically been implied by going in the direction of increasing t. I started at the origin, and then I went over 2 and up 1, and then over 2 and up 1, over 2 and up 1. So my arrow is in there correctly. The last thing I want to do is re-express this in the ordinary rectangular form. So I want to eliminate the parameter t to get this done. I have x equals 2t, y equals t. So this is a very simple eliminating the parameter. Another name for t is just y, so I can replace it in the top equation. And I get x equals 2y. Putting it in a more standard form, y is equal to 1/2 x. And I recognize that as the equation of a line with slope 1/2 passing through the origin, which is exactly what we constructed here. The only difference is that this is just a line segment because I'm only going from that starting point when t is 0 to the ending point when t is 3.